Hi and welcome again to another tutorial, folks. In this tutorial we are going to actually create a 2-bit input and 7-segment display. So we're going to input the number in binary and then convert that into decimal, and that would be displayed using 7 segments. 0 1 goes to 1, 1 1 goes to 3, and 1 0 goes to 2. Okay, so this is your 2-bit 7-segment display. So let's get started. So I'm gonna actually create a logic circuit, and for that I would have to create and analyze a circuit. So say our inputs, because it's a 2-bit input, so we're gonna have 2 switches. Say those are switch A, switch B, and the outputs, because the output is going to be displayed on 7 segments, so it's important to see the pin configuration of 7 segments. So here is a 7 segment. This segment represents A, B, C, D, E, F, and the middle one is G. This is a decimal point right here. We're just going to ignore it because we're not going to be using it. So we would have basically 7 outputs: A, B, C, D, E, F, and G. So let's go back to Logisim, and here I'll use a lowercase a, B, C, D, E, F, and G. Okay, I'm going to click add here and I'm going to move to the table. Alright, so when switch A and switch Z both are 0, that means it needs to display 0 because the binary code of 0, the decimal of the binary code 00 would be 0. So all of these needs to be 0. Now another thing here we need to decide is whether we were going to go with the active low logic or active high logic. So for example, I'll go back to again this pin configuration. If both the switches are set to 0, that means it needs to display 0 here, which would mean A, B, C, D, E, and F would lit up and G segment would be off, and that would display 0. Okay, that can be done 2 ways. These 7 segments are either active low or either active high. You'll see another of my lecture in which I explain what's the difference between the two, but we'll just keep it simple in this tutorial and we'll go with the active high, meaning if A needs to be light up, then this needs to be set to 1, or if B needs to be light up, then B needs to be set to 1. So in other words, if both the switches are set to 0, switch A and switch B, that means it needs to display 0. So A, B, C, D, E, and F needs to be set to 1. Okay. Alright, so let's go back to, we'll change that to 1. This is what we know as active high. All these segments will be 1 except for G. G will be 0. Okay, now we're gonna move on to 0 1. 0 1 makes a binary code of 1, which would mean B and C needs to be high and rest of the other segment needs to be 0. Okay, alright, 1 and 0 makes a binary code of 2, which means C and F needs to be 0 and all of the other segment needs to be high. And 1 1 makes a binary code of 3, so which would mean E and F needs to be 0, and all of the other segment needs to be high. Okay, so we have finished the truth table, and we are going to click on build circuit now. So this is our 2-bit 7-segment. Click OK, and it should have the circuit right here. Okay. So here is our logic circuit diagram. We created a truth table. We then built a logic circuit using Logisim. Now we are going to connect these outputs to the 7 segments. So I go here, I'm gonna have to look at the 7 segment Logisim. There's it. Okay. Now notice over here, this is segment A, which is connected to this dot right here. This is segment B. It's connected to this dot right here. This is important to know because we will be actually making connections. So I'm going to insert a 7 segment here. So I go to input output and I drag this 7 segment over here. Okay. Now again, I'm gonna keep on pulling this this tab right here. A is connected to this dot right here, so I need to connect A with this dot right here. B needs to be connected to this dot right here. Okay, what about C? C is this one, which is connected to this dot right here. So I'll just connect C. Remember, this dot represents a decimal number. Okay. Now we have D, which is connected to this dot, and E is connected to this dot right here. E is connected to this dot right here. Now we need to connect F and G. So let's see where F and G is. This one is F. This dot is connected to F, and this dot is connected to G. Okay. All right. So let's connect F first. Okay, and this is G. So then you connect this one. Now notice, because both the switches are set to 0, 0, it's making a binary code of 0, which is in decimal 0. If I change the switches from 0, 0 to 1, 1, that makes a binary code of 3, so you see 3 over here, correct? Similarly, 1, 0 will make a code of 2, and then 0, 1 will make a binary code of 1, and that's what we see over here. So this is your 2-bit 7 segment display where you have 2-bit input switch A and switch B, and they make up a decimal code which can be displayed on a 7 segment. Now we're going to take this project to the next level by actually doing it using the real chips. Okay, and for that we would need a Boolean expression. So one of the good ways of doing this is if you go over here, you can right click here, and then you can go to Analyze Circuit, back again. If you click on this expression tab, it will basically give you 7 expressions for A, B, C, D, E, F, and G. Okay, those are these expressions right here. Okay, and we can connect these 7 outputs with the 7 segment to display our output. Okay, and now we're gonna do this with real chips. So notice we need 3 OR gates, 1 AND gate, and 1, 2, 3, 4, 5, 6 inverters. Okay, all right. So we are going to create this circuit using the logic ICs, and we are going to use the Tinkercad. So you have seen simulation with Logisim, and you're gonna do the same thing with Tinkercad now. Like I mentioned before, we need 3 OR gates and 1 AND gate and 1, 2, 3, 4, 5, 6 inverters. Okay, so let's look at the pin configuration of these chips. Okay, so we need 7408, which is the AND gate. Okay, we need only 1 gate, so this should work out. We need 4 OR gates, 3 OR gates actually, so we can use 7432. It has 4 gates, we only need 3 of them. And then the inverter, this is right, 7404, and it has 6 inverters, and that's all what we need. Okay, with pin number 1 being input and pin number 2 being output. Similarly for AND gate and OR gate ICs, pin 1 and 2 is input and 3 is output, and so on. Okay, alright, so let me go to Tinkercad now. I'm going to drag a breadboard first. We need 2 slide switches. Move in a little more. This is my switch A. I need another switch. This is my switch B. Cell 3-volt battery would work. I need a 7408, which is AND gate. I need an inverter, which is 7404. I need an OR gate, which is 7432. Remember, for inverter, pin number 1 is input, pin number 2 is output, pin 3 is input, and pin number 4 is output, so and so on. Here for the 7432, which is an AND gate, which is an OR gate. It's an OR gate. So pin number 1 and 2 are inputs, as you can see over here. Okay, and pin number 3 is the output. For inverter, pin number that's an AND gate. Pin number 1 and pin number 2 are the input. Pin number 3 is the output. Okay. What else we need? We need a 7th segment also. Remember, we have the LEDs going into each of these pins right here. So we would need resistors as well. So I'm gonna use the bottom 2 rails as my switch A and switch B. So this is my switch A, my switch B. I'm gonna color them as blue. So these are my switches. Okay. This needs to be, so the positive goes here. So I'll make it red. And then the negative. Right. Now notice again it has the same pin configuration, pin 8. This is pin number 8, B, C, this is for decimal point. Okay. So now, and also notice here in the pin configuration, pin number 7 is ground in all the cases, and pin number 14 is VCC. So let's make those connections also. Pin number 14, pin number 14, and pin number 14. Okay. Pin number 7 is ground. There you go. Okay. And similarly over here, these are supposed to be connected to positive, and these are supposed to be connected to negative. Okay. So black, red. This goes to positive again. Black. We would also need resistors, so I'll just pull one here, and we would need 6 of those because we got, actually 7 of those because we got 7 segments. And let's the value of like 100 ohms. Okay. And then I'm just copying and paste it 3, 4, 5, 6, 7 of those. Okay, now let's work on the expression A first. Okay, now the expression for A is word of switch B ORing with switch A. Okay, okay, we need to create invert of switch B first. Our inverter is 7404, which is one right here. So I'm going to connect this to switch B. Remember, this is our switch B, which is the bottom rail. Okay, and the invert of that becomes the output, which is the invert of switch B, becomes the input of one of the input of the OR gate. And then it's ORing with what? It's ORing with switch A. Okay, alright. Oh, I accidentally clicked on Camtasia. Okay, so this is supposed to be connected to switch A, which is right here, and the output should be connected to through one of the resistor. Now change the color to purple, so all my purples will be inputs going into the 7 segment. Okay, so A is done. I'm gonna work on B now. See what's the expression for B. B is 1, so I just simply connect the B. Let me just move this over here. I'm gonna work on the expression C. C is, okay, invert of switch A plus switch B. So this is my OR gate. One of the input is switch B, okay, which is right here. I need invert of switch A, so I need to connect this to switch A, and this is the invert A that goes into this slot right here, and the output is now connected to C, which is right here. And you change the color to purple. Okay, there's one thing I need to make sure here, that I need to insert the resistor. Okay, now put it over here. And change the color to purple again. And similarly, I'm going to do it for D, E, and F also. Let's go to D. Invert of switch B, ORing with switch A. Okay, the circuit is pretty much ready. We just need to make a connection here. The common needs to be connected to the negative terminal of the battery, because we are going to use that as a common cap. Okay. Alright, so that is pretty much done. I'm going to change the color to black here. Okay, and hopefully this should work. So let's try it. You click on Start Simulation. Okay, alright, the switch position is set to 0 and 0, and that's what you see. I'm going to change it to 0, 1. Remember, this is your switch A, okay? 0, 1 goes to 1, 1, 1 goes to 3, and 1, 0 goes to 2. Okay, so this is your 2-bit 7-segment display. This is we did it 2 ways. We did it using Logisim, we did it using Tinkercad. In old days, we used to do something like this. You'll have a bunch of wires. We don't do it, but I just wanted to have a feeling of that, like how things can, go crazy with these digital logic circuit diagrams. With this, I'm going to finish this tutorial. I hope you enjoyed it, and I'll see you guys in the lab. Thank you for watching. Bye.